NEC Section 440.14b2 permits the use of non-fused disconnect switches, or NFDS, for disconnecting motors and controllers. Importantly, NEC Section 440.14b4 specifically provides an exemption for packaged rooftop air conditioning units from the requirement to have fused disconnect switches, or FDS. This means that if a packaged rooftop air conditioning unit does not have a factory-installed disconnect, a non-fused disconnect switch is permitted under the National Electrical Code. It is crucial to ensure that the branch circuit that is feeding the rooftop air conditioning unit is properly protected by a circuit breaker or fuses. This protection must be in accordance with NEC Section 440.22. Furthermore, it is essential that each individual motor within the air conditioning unit has its own individual overcurrent protection. This protection is typically achieved through the use of a motor starter or controller and must comply with the requirements outlined in NEC Sections 430.32 and 440.22. It is not uncommon for misunderstandings of the code to occur, or for local regulations to have specific requirements that differ from the national code. Therefore, it is always recommended to clarify any questions or concerns with the local authority having jurisdiction, or ARCH. These authorities are responsible for interpreting and enforcing the electrical code within their specific region. When installing or inspecting electrical equipment such as packaged rooftop air conditioning units, it's critical to refer directly to the most current edition of the National Electrical Code, as well as any applicable local amendments or regulations. This ensures that all installations are safe and compliant with the relevant standards. In the context of electrical installations, a disconnect switch serves a crucial function. It's a device used to isolate electrical equipment from its power source, allowing for safe maintenance, repairs, or replacement. Disconnects are designed to provide a visible break in the electrical circuit, giving electricians and other qualified personnel a clear indication that the power is off. A fused disconnect switch, or FDS, is a type of disconnect switch that incorporates fuses within its design. These fuses provide overcurrent protection for the equipment being served. If an overcurrent condition occurs, the fuses will blow, interrupting the circuit and preventing damage to the equipment. An unfused disconnect switch, or NFDS, on the other hand, does not contain fuses. It simply provides a means of disconnecting the equipment from its power source. In situations where overcurrent protection is required, it must be provided separately, typically at the branch circuit panel. The National Electrical Code, or NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years to reflect the latest advancements in technology and best practices in electrical safety. The NEC is not a law itself, but it is widely adopted by state and local jurisdictions, making it the de facto standard for electrical installations. Understanding the specific requirements of the NEC is essential for electricians, engineers, inspectors, and anyone involved in the design, installation, or maintenance of electrical systems. Section 440 of the National Electrical Code specifically addresses air conditioning and refrigeration equipment. This section provides requirements for disconnecting means, overcurrent protection, motor controllers, and other aspects of electrical installations related to these types of equipment. It's crucial to carefully review and understand the requirements of Article 440 when working with air conditioning and refrigeration systems to ensure compliance with the NEC. Overcurrent protection is a critical safety feature in electrical systems. It's designed to protect wiring and equipment from damage caused by excessive current flow, which can result from short circuits, ground faults, or overloads. Overcurrent protection devices, such as circuit breakers and fuses, are designed to automatically interrupt the circuit when an overcurrent condition is detected. This prevents overheating, fires, and other potential hazards. Motor starters and controllers are used to safely start and stop electric motors. They also provide overload protection to prevent damage to the motor in the event of an overcurrent condition. Motor starters and controllers come in a variety of types and sizes, depending on the size and type of motor being controlled. They typically include features such as overload relays, which trip the starter if the motor draws excessive current for an extended period. The authority having jurisdiction, or OJ, is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, an installation, or a procedure. The AHJ may be a local building inspector, a fire marshal, or another designated official. It's important to work closely with the AHJ to ensure that all electrical installations are compliant with applicable codes and regulations. When installing a non-fused disconnect switch for a packaged rooftop air conditioning unit, it's important to consider the following factors. Firstly, the size of the disconnect switch must be appropriate for the size of the air conditioning unit and the ampacity of the branch circuit. Secondly, the disconnect switch must be readily accessible and located within sight of the air conditioning unit, as required by the NEC. Thirdly, the disconnect switch must be properly labeled to indicate its purpose. Fourthly, the branch circuit feeding the air conditioning unit must have appropriate overcurrent protection, such as a circuit breaker or fuses to protect the wiring and equipment from overcurrent conditions. Fifthly, all wiring connections must be made in accordance with the NEC and manufacturer's instructions. Sixthly, the installation must be inspected by a qualified electrical inspector to ensure compliance with all applicable codes and regulations. In addition to the National Electrical Code, there may be local amendments or regulations that apply to electrical installations in a specific area. These local requirements can vary from jurisdiction to jurisdiction, and it's important to be aware of them when planning and executing electrical work. Local amendments may address issues such as wiring methods, grounding requirements, or the types of equipment that are permitted to be used. To determine if there are any local amendments in effect, contact the local building department or electrical inspection agency. They can provide information on any specific requirements that apply to electrical installations in that area. It's also important to note that some local jurisdictions may have stricter requirements than the NEC, while others may have less stringent requirements. It's always best to err on the side of caution and follow the most stringent requirements to ensure the safety of the installation. In some cases, local authorities may have specific interpretations of the NEC that differ from the interpretations of other jurisdictions. These interpretations can be based on local conditions or specific concerns. It's important to be aware of these local interpretations when working in a particular area, as they can affect the way that electrical installations are performed. If there is any doubt about the proper interpretation of the NEC in a particular situation, it's always best to consult with a local authority having jurisdiction to obtain clarification. They can provide guidance on how to comply with the code in a way that meets the specific requirements. The National Electrical Code provides a comprehensive set of rules and guidelines for electrical installations, but it's not always possible to anticipate every situation that may arise in the field. In some cases, it may be necessary to deviate from the specific requirements of the NEC in order to address a unique situation or to achieve a specific objective. However, it's important to obtain approval from the local authority having jurisdiction before deviating from the NEC. The AHJ can review the proposed deviation and determine whether it is acceptable based on the specific circumstances. They may require additional safety measures or modifications to the installation to ensure that it meets the intent of the NEC. Deviating from the NEC without approval from the AHJ can result in code violations, fines, or even the shutdown of the installation. Therefore, it's always best to seek approval before making any changes that are not explicitly permitted by the code. Continuous training and education are essential for staying up to date with the latest changes in the National Electrical Code and other relevant standards. The electrical industry is constantly evolving, and new technologies and best practices are emerging all the time. By participating in continuing education courses, attending industry conferences, and reading trade publications, electricians, engineers, and inspectors can stay informed about these changes and ensure that they are providing the safest and most efficient electrical installations possible. Continuing education courses are offered by a variety of organizations, including trade associations, educational institutions, and manufacturers. These courses cover a wide range of topics, including the NEC, electrical safety, motor controls, and renewable energy. Industry conferences provide an opportunity to network with other professionals in the electrical industry and to learn about the latest products and technologies. Trade publications provide valuable information on new products, code changes, and best practices. By taking advantage of these resources, electrical professionals can stay ahead of the curve and provide the highest quality services to their client. The National Electrical Code is not the only standard that may be relevant to electrical installations. Other standards, such as those published by the National Fire Protection Association, or NFPA, the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI, may also apply. The NFPA publishes a wide range of codes and standards related to fire safety, including NFPA 70E, which addresses electrical safety in the workplace. The IEE develops standards for electrical and electronic engineering, including standards for power systems, telecommunications, and information technology. ANSI accredits organizations that develop standards for a wide range of products and services. It's important to be aware of these other standards and to comply with them as applicable. In addition to complying with the National Electrical Code and other relevant standards, it's also important to follow manufacturers' instructions when installing electrical equipment. Manufacturers provide detailed instructions on how to install their products safely and effectively. These instructions should be followed carefully to ensure that the equipment is installed correctly and that it will operate as intended. Failure to follow manufacturers' instructions can result in equipment failure, electrical hazards, or even injury. Therefore, it's always best to take the time to read and understand the manufacturer's instructions before beginning any electrical work. When working with electrical equipment, it's essential to use appropriate personal protective equipment, or PPE. PPE is designed to protect workers from electrical hazards, such as electric shock, arc flash, and arc blast. Common types of PPE include safety glasses, gloves, and flame-resistant clothing. Safety glasses protect the eyes from flying debris and other hazards. Gloves protect the hands from electric shock and burns. Flame-resistant clothing protects the body from burns in the event of an arc flash. The type of PPE that is required will depend on the specific task being performed and the potential hazards involved. It's important to assess the risks and to select PPE that provides adequate protection. Before beginning any electrical work, it's important to energize the circuit or equipment that will be worked on. The energizing means turning off the power and verifying that the circuit is dead. This can be done by opening the circuit breaker or removing the fuses that supply power to the circuit. Once the circuit has been de-energized, it's important to verify that it is dead using a voltage tester. A voltage tester is a device that is used to detect the presence of voltage in a circuit. If the voltage tester indicates that there is no voltage present, then the circuit can be considered dead and it is safe to work on. It's important to follow lockout/tagout procedures when de-energizing electrical equipment. Lockout/tagout procedures are designed to prevent accidental energization of equipment while it is being worked on. These procedures involve placing a lock and tag on the circuit breaker or disconnect switch to prevent it from being turned on. The lock and tag should only be removed by the person who is performing the work. When working with electrical equipment, it's important to maintain a safe working distance from energized parts. A safe working distance is the minimum distance that a worker must maintain from energized parts to avoid the risk of electric shock or arc flash. The safe working distance will depend on the voltage of the equipment and the type of work being performed. The National Electrical Code provides tables that specify the safe working distances for various voltage levels. It's important to consult these tables and to maintain the appropriate safe working distance at all times. Arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical circuit. Arc flashes can generate extremely high temperatures, intense light, and concussive forces. They can cause severe burns, blindness, and even death. To protect workers from arc flash hazards, it's important to perform an arc flash hazard analysis. An arc flash hazard analysis is a study that is conducted to determine the potential arc flash hazards in a particular electrical system. The analysis will identify the locations where arc flashes are most likely to occur and the severity of the potential arc flash hazards. Based on the results of the arc flash hazard analysis, appropriate protective measures can be implemented to reduce the risk of arc flash injuries. These measures may include the use of arc-rated personal protective equipment, the installation of arc flash barriers, and the implementation of safe work practices. Electrical safety is a critical concern in the workplace and at home. By following safe work practices, using appropriate personal protective equipment, and staying up to date on the latest electrical codes and standards, it's possible to minimize the risk of electrical hazards and to create a safer environment for everyone. When selecting a non-fuse disconnect switch, ensure it is horsepower rated if used to directly disconnect a motor. The horsepower rating should equal or exceed the motor's horsepower rating. This is crucial for safely interrupting the motor's current. Also, verify the disconnect switch's ampacity rating matches or exceeds the circuit's maximum current. Choose a switch with an appropriate short circuit current rating, or SCCR, to withstand potential fault currents. The SCCR should be equal to or greater than the available fault current at the installation location. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. Bonding connects all metal parts of the electrical system to create a low impedance path for fault current. This helps to ensure that all metal parts are at the same potential, reducing the risk of electrical shock. Grounding and bonding must be performed in accordance with the requirements of the National Electrical Code. Electrical systems should be inspected regularly to identify and correct any potential hazards. Inspections should be performed by qualified electrical inspectors who are familiar with the National Electrical Code and other relevant standards. Inspection should include a visual examination of the wiring, equipment, and grounding system. Inspectors should also test the operation of overcurrent protection devices and other safety equipment. Any defects or hazards that are identified during the inspection should be corrected promptly. Remember to consult the manufacturer's data for the specific rooftop unit to understand its electrical requirements and any specific recommendations for disconnect types or overcurrent protection. This information is crucial for a safe and compliant installation.